All right, question 9. So yeah, we've got repeated root in the denominator. So we're going to turn this into 5x plus 3 equals a over 2x plus 1 plus b over x plus 1 plus c over x plus 1 squared. So that's how we deal with a repeated root. In the denominator, we have the root repeated with c, and we have the root on its own with b. The rest of this is as it was before. iPad's frozen a bit there. Okay. That's really weird. Okay. Okay. So yeah, 5x plus. It appears my pen has stopped working, which is not good. Oh, there we go. All right. 5x plus 3 equals. All right. So a needs to be, every time we're trying to think of what we need to times each bit by, I always say to myself, what do I need to times a's fraction by to get that denominator there? So in a's case, it's got the 2x plus 1 bit. We just need to times x by x plus 1, times a by x plus 1 squared. And then you can imagine that the whole denominator will turn into the thing we have in the initial fraction. All right, b. Now b has one of the x plus 1's, but it needs the x plus 1 squared, so we need to times it by 2x plus 1 and x plus 1 in order to get the squared bit. And last of all, I always run out of room in these. Last of all, c needs to be times by 2x plus 1 because it already has the squared part. All right, now we're going to do some substitutions. So we're going to say x equals minus 1. So we get minus 5 plus 3 equals c times minus 2 plus 1 is minus 1 there. So we get minus 2 is minus c, so c equals 2. So I can put that up top there right now. And next term, we're going to substitute x is equal to minus a half. So we're going to get minus 5 over 2 plus 3 equals a minus a half plus 1 all squared. So we get half equals a minus a half plus 1 is going to be a half squared, so it's a over 4. So a also equals 2. Right, b is a little bit trickier because we've substituted everything in already. So what I always say is substitute in something that looks easy. So maybe substitute in x is 1 or x is 0 would be my choice. So I'm going to put let x equal 0. So we're going to get 5 lots of 0, 0 plus 3 is 3. A we know is 2, so we're going to get 2 times 1, which is just 2. Plus b, well we're going to get, each of these brackets is going to turn into 1, so we just get b on its own, b times 1. Plus c, and again times 1, so this was a really easy one to do. So I worked it out, 3 equals 2 plus b plus 2. Take away 4 from each side, we get b is minus 1. So there we go, my final answer is there for my partial fraction. So just make sure you don't get your a, b, and c mixed up. So just to recap, be careful with the roots, you need to have that repeated part kind of on its own and repeated. When you times to multiply out, maybe you're trying to turn each of these fractions to have the same denominator as the fraction you started with. So we need to times the first fraction by x plus 1 squared, you can see that there. Second fraction we needed to times by 2x plus 1 and x plus 1 to get there. And the last one we just needed to times by 2x plus 1. And put the values in as normal. The last value though, pick something easy, substitute it in, use the values you've already found for, in this case, A and C, and then solve to try and find B. That's it.